Alright, let's see how you did on the guided practice problem for Objective 2. Your task was to solve the logarithmic equation 2 times the natural log of the argument cube root of x plus 1 minus 5 equals negative 1. As is in Objective 1 and Objective 2, our first step is to isolate the logarithmic expression. We do so with simple algebra. In this case, we want to eliminate the minus 5 by adding 5 to both sides. Negative 1 plus 5, 4. On the left-hand side, minus 5 plus 5 eliminate, and we're left with 2 times the natural log of the cube root of x plus 1 equals 4. Then we need to divide both sides by 2. On the left-hand side, the times 2 and the divide by 2 eliminate. 4 divided by 2 is 2. So now we have an isolated logarithmic equation, or isolated logarithmic expression in our equation. So the next step, again, similar to, or exactly the same, I should say, as Objective 1, we need to eliminate the logarithm by taking the natural exponential function of course, both sides of the equation. So here's our equation. We apply e to the x, or the exponential function, to both sides. So e to the natural log of the cube root of x plus 1 equals e to the right-hand side was 2, so e squared. On the left-hand side, the exponential function and the logarithmic function eliminate, and we get the argument of the log, cube root of x plus 1 equals e squared. Remember, on the right-hand side, the e does not eliminate because it did not have a logarithmic expression. Our next order of business, once we have eliminated the logarithm, and now we have a cube root, or a radical equation, we need to isolate the cube root and cube both sides. So here's our cube root of x plus 1 equals e squared. The only thing we need to do to isolate the cube root expression, subtract 1 from both sides. Once we have an isolated radical, in this case the cube root, we will eliminate the cube root by cubing both sides. Cube both sides. So on the left-hand side, the cube and cube root eliminate. We're left with the argument x equals quantity, the entire right-hand side, cubed. So e squared minus 1, it needs to be in parentheses, cubed. That is our proposed solution. And as usual, we're going to need to do a domain check. Alright, we're going to do a fairly quick domain check this time. Remember, we need to check to make sure that our proposed solution, when we input our proposed solution for x into the argument of the log, that we're actually taking the log of a positive number. So it's not enough just for x to be positive, or it might not even matter whether x is positive. What matters is when we put it in, what we're taking the log of is positive. So in this case, we're going to use an approximation. X is the exact value of x is quantity e squared minus 1, quantity cubed, which if you put that in a calculator, again I encourage you to put it in your calculator and make sure you come up with the same approximate solution, 260.8. We plug that into the argument of the log. Well, the cube root of 260.8 plus 1. The cube root of a positive number will be positive, plus 1. We'll keep it positive. That's greater than 0. We're good.